Hi guys and ladies, welcome to Welding with Joe. Today we're going to be doing some brazing on a radiator. Here we have a copper brass radiator and I need to modify the inlet on it. Now this is really probably the worst example I could be giving for my first welding series video, but I don't hardly ever do any brazing, so I definitely wanted to document this as it's coming through my shop and I have the opportunity. It's been a while, I'm a little rusty, but I'll give you the best advice I can here. You can follow along and see how it turns out. This is also going to double somewhat as an instructional video for some of my doomsday diesel conversions, so that's another reason why I needed to document this and get this out here right at the beginning. So let's bring in and I'll show you what we're working on. All right, so we're looking at the top of the radiator here, and you can see the inlet for the radiator actually kind of veers off and it goes towards the right hand fender. And that's not going to work for our swap that this radiator is going into. We need it to come out perfectly straight. So we are actually going to cut this off, clock it, and braze it back on. So our first step here will be to clean all of this paint off, and we're going to do that before we cut it off. That way we're only taking the wire brush and going around once instead of having to clean two parts individually. We'll use some acetone to wipe off any residual oil or grease, and then we'll prepare to set up our welder. So we got our part all cleaned off here. And now I want to show you several things about the prep. When we cut this off, there were burrs all over it. Go get yourself one of these cheap little deburring tools. They're about 10 bucks. They come with these replaceable deburring tips. You can store them underneath the cap on the back. You'll take this and run it around the inside, and that cuts all the burrs off the inside. Next, I'll recommend, if you're going to be doing a lot of TIG welding or welding on dirty material, go buy yourself one of these gallons of acetone. They're like $9 at your hardware store. And get some cheap paper towels and some gloves. A lot of people will be idiots and not wear the proper PPE, and this will dry your hands out in a heartbeat, especially in the winter time. You just soak a paper towel, the acetone, and clean your parts up, because when it comes to brazing, cleanliness is absolutely critical. And then when it comes to using brake parts cleaner, I want to mention this red can is chlorinated. This can absolutely not be used anywhere in the vicinity that welding is going to occur. You need to use the green can, which is the non-chlorinated version. Now it does say in the fine print on the back that you'll die if you use this and then you weld. But it really needs to be in big, bold letters on the front. Do not weld near. What happens is the UV rays mix and react with the chlorine and create phosgene gas, which was used to kill people in World War I. It's really nasty stuff. If you spray this anywhere close, if you're in a garage and you spray it in one corner of the garage and you think you're going to go weld in the other corner, you could still die, because this stuff will migrate and it reacts with that UV ray. It smells kind of like fresh cut alfalfa. I've experienced it. Unfortunately, I was never told about phosgene gas in any of my classes. I had to learn from the School of Hard Knocks. I almost died just trying to properly clean an aluminum weld joint, and now I only buy the green stuff. Another tool I forgot to mention that you'll absolutely need is a respirator. You do not want to breathe the fumes in when you're doing this process. And I also have my Lincoln Mobiflex fume sucker, which keeps the fumes from permeating throughout my shop. So I've picked up this tube of silicon bronze filler. It's some cheap Chinese stuff off Amazon, but I only wanted 1 pound to try it out. If I bought it from my local welding store, I had to buy 10 pounds, which was $200. And like I said, I'm not doing that much brazing, so we'll go with this. Now, one thing a lot of times people won't tell you is you actually want to take your acetone cloth and wipe off your filler material, because there's protective oils and coatings on a lot of these to keep them from rusting when they're floating across the ocean. And you'd be amazed at all the crap we'll get off. So those dark black lines there, that's all the stuff that came off. Here I'm using the Aspect 230 from Lincoln Electric. This is an AC/DC TIG welder. It's essentially their second best welder. The Aspect 375 would be the highest end TIG welder you could get. I don't need that much amperage, and that's way out of my price range. So this has most of the features of the larger unit, just in a smaller package, and you can control anything and everything you pretty much could want to control. We'll be trying out a 2% lanthanated tungsten, and I only recommend getting quality tungsten. I've tried lots of cheap Chinese tungstens and none of them work well. Okay, so now we're going to set up our welder for our brazing. I've tried this in two different modes. I've tried it DC without pulse and DC with pulse. And the DC without pulse will work if you do it in phases. You're going to have to let the part cool off and come back to it. Just no pulse, straight DC. I was running at 60 amps max. I'm not sure exactly where I was actually welding. And then with pulse, so we're going to come in here, we're going to turn our pulse on. We'll go through our settings. So I got my max amperage set at 60. Now, they do a really good job of showing this in a visual sense, what the pulse settings are here. So first we go to our percentage here. So I'm actually going to go forward to our frequency, which is Hz, hertz, which is times per second. And that is this group right here. That's the whole thing. And that's going to be the length or the duration. So the whole pulse, the max and the min, will last 0.7 seconds before it starts back over again. And you can change that. Here's once per second, twice per second, so on and so forth. I've got it at 0.7. Now we'll have to cycle back through and go to our percentage here. It says peak. And then you adjust this number in increments of 5. And this is the percentage of that pulse duration that the machine will run at the peak amperage. So here we have it set 55% of the pulse will be at our peak amperage, which means 45% will be at our background amperage. And so the last thing you get to do, and they show you here, they got an arrow going up and down for this last one. This is the background amperage in a percent of the peak amperage. So our peak amperage is 60. So here you can increase, decrease in units of 1%. I've got it at 15%. So 15% of 60 is 9 amps. So this means for 45% of 0.7 seconds, will be at 9 amps, and then at 55% of 7.7 seconds will be at our max 60 amps. So you really get a lot of control out of this. Now, why did I choose these settings? I had to play with it, and when I'm setting up a new welding procedure, I always say, only change one variable at a time. Don't go in here and change 5 different things, because if something doesn't work, you don't know what you change that makes it not work. It's really easy to get carried away in here, but eventually I landed on these settings. They're not perfect, but you basically want to focus your arc on the filler, not on the brass, and get it to melt and wet out. And then I'm using that pulse to go to a super low amperage of 9 amps. And the reason I'm doing that is basically because I don't want to terminate my arc, but I don't want to put any heat into that weld joint anymore. I want to let it freeze. I want that brass to cool back down, because our brass has a lot of zinc in it, and if you bring the brass up to its melting point, that zinc starts coming out, and it's toxic, it's bad for your health, it's bad for the joint. You can get porosity in your joint really easy if you melt the brass and let that zinc start outgassing. So I've got it set at a really short duration of pulse. It's only 0.7 seconds long, so that we are freezing that puddle and it's easy to visually see. And for this process, it worked okay. So here's the end result. It's definitely not pretty, but it passed my leak test with flying colors. If it can pass that, it should definitely hold water. The leak test I do simulates hot engine oil. So I ended up having to resolder the tube here into the radiator end cap as well. Would I recommend doing this brazing modification for your Doomsday Diesel Toyota swap? No, I wouldn't. It's extremely difficult to braze this brass tube. It's really dirty. It's really fumy. You can see how bad it was when I started out. Big globular transfer. And once I got to the end, it wasn't too bad. I still really don't even want to put this on film. But it's important that you know how difficult this is before you go out and decide you're going to tackle this head on. If I could do this again, I would try just heating this up and gently forming it into the direction I want. And if that doesn't work, I'd like to see if I could just cut this off and find a tight fitting sleeve to go over the outside and then solder it on straight. Because obviously the solder's a super simple process to do. This tube actually goes all the way down into this radiator, and it's actually a formed piece. It goes into a plate and it's attached to the cap. So I actually melted this solder out and tried to pull this out, and it won't come out. It's an integral piece. So thanks for joining me for our first technical Welding with Joe video. Hopefully you learned something. I know I did. This was a terrible video for my first video in the series, but again, I'm hardly ever going to be trying to braze brass, so I wanted to take advantage of the opportunity, show you guys a real world application for it. I promise you the rest of the series I'm going to focus on the stuff that I am an expert on. I look forward to it. Can't wait to show you the next video. Hope to see you there. Thanks, guys.